welcome to the deep dive. Okay, let's start with something.
Yeah.
Well, pretty mind-bending. What if I told you your brain isn't just seeing reality, it's actually making it up as it goes?
Uh-huh.
Neuroscientists actually talk about this. They call our brains prediction machines. The idea is that perception is basically a kind of controlled hallucination.
Right. It's constantly guessing what's out there and then just sort of tweaking the guess based on what our senses tell us.
Exactly. It's always predicting, filling in blanks, generating the world we experience. It's kind of fundamental to how we work. And today, in this deep dive, we're going to explore how that surprising idea about us totally changes the game for thinking about artificial general intelligence, AGI.
Yeah, it's not just some weird neuroscience fact. It could be key.
It really reframes things, doesn't it? Our own minds, the future of AI, all of it.
Absolutely. So our mission today really is to unpack this vision coming out of Amazon's AGI SF lab. It really pushes back against the usual AGI narrative.
The standard sci-fi stuff.
Kind of, yeah. It challenges that folklore by looking way back historically and focusing on, surprisingly, augmenting us, humans, not just building smarter machines in a vacuum.
Interesting. So our main source for digging into this is Danielle Persick, who's a cognitive scientist over at Amazon AGI.
That's great.
She talks about something called useful general intelligence and how her team's building AI specifically to complement us, to work with our intelligence.
Right.
So, okay, let's unpack this. Let's circle back to that hook. The brain predicting, then fixing errors based on what comes in, this controlled hallucination thing. The crucial point seems to be that for any kind of flexible intelligence, human or AI, being able to go beyond the raw data, that's not a flaw.
No, it's a feature, absolutely essential. Predicting, imagining, taking that leap.
Yeah.
You need to adapt, right? To handle things you haven't seen before.
Okay, I see that.
And you can see the connection to AI already, can't you? We use chatbots that hallucinate all the time for brainstorming, writing.
Yeah, creating images even.
Yeah, exactly. So the problem isn't that they hallucinate, it's figuring out how to, well, control it, like our brains do.
Ah, okay. Control's the key.
Right. And this points to a deeper philosophy, I think. The goal isn't necessarily replication or replacement.
Not building a copy of us.
No, it's about complementing us. You know, the aim is for AI plus humans to be better together than either could be alone, greater than the sum of the parts.
That sounds, yeah, really positive. And it highlights what they call a category error in how we usually think about AGI.
What's that?
This idea that you can have general intelligence just sitting inside one machine, isolated.
Right. Like some super brain in a box.
Yeah. And then we look at current agents and think, they seem close, but why can't they just reliably, like, click a button on a website or scroll properly?
It feels clunky sometimes.
Exactly. That disconnect.
Yeah.
It suggests maybe we're missing something fundamental about what intelligence is.
And that category error, it really makes you step back and ask, well, where did this standard brain in a box idea come from anyway?
Good question.
If you look back, there are kind of two main historical threads for building advanced intelligence. The first one, the standard vision, really kicked off around that 1956 Dartmouth conference, the birthplace of AI, basically.
Right.
And that vision was all about building thinking machines, making the AI smarter, giving it more agency. The focus was purely on the tech itself.
Okay, that sounds familiar.
But, and this is crucial, that wasn't the only idea floating around back then. You also had Douglas Engelbart.
The mouse inventor.
And
Graphical interfaces.
very same. And he wasn't really aiming for thinking machines. He was focused on thinking humans. How could computers augment our abilities, make us smarter?
Ah, a totally different angle.
Totally. He saw tech changing us. We offload stuff to devices. We spread our thinking out digitally. He called it techno-social co-evolution. We invent tech, and the tech changes us.
Wow. So make AI smarter or use AI to make us smarter. Two paths.
Pretty much.
That is a really powerful difference. So this augmentation idea, if we focus on that, what does it mean for AI to be useful? How do we even measure that?
Well, useful things tend to do one of two things, right? They either simplify life, let us offload boring tasks, or they give us more leverage, more power to do things.
Okay, like automation.
Exactly. And automation can definitely drive augmentation. Think about how our brains automate skills like driving or typing. It frees up our conscious mind.
Right, moves it to the subconscious.
Precisely. But, and this is the catch, automation doesn't always lead to positive augmentation. It's not automatic.
Ah, there's the nuance.
Yeah.
Because sometimes automation can, well, backfire.
Absolutely.
Yeah.
Think about mindless scrolling. hours lost. Or autocomplete, kind of.
Sure.
Short-circuiting your own thinking process sometimes.
Yeah, I felt that.
These algorithms can actually end up reducing our agency, boxing us in, echo chambers, things like that. So smarter agents, if they're not designed right, could actually create more problems.
So the Amazon AGI Lab's vision, it's trying to avoid that trap.
That seems to be the core idea. Building AI that unhobbles humans, makes us smarter, gives us more agency. It flips the script from just making the AI itself smarter.
Okay, unhobbling humans.
Yeah.
I like that. So how are they actually doing that with this NOVAAG thing they previewed?
Yeah.
What does it look like?
Well, first off, they're trying to make it easy to use. Meeting developers and the models where they are. Low friction.
Practical?
Yeah. And their big vision, it's pretty bold. Eventually, the atomic unit of all digital interactions will be an agent call.
Wow. Everything becomes an agent action.
That's the idea. The big hurdle now, though, is that most of the web is built for eyeballs, right? Visual UIs, not neat APIs for computers to talk to.
True. It's messy.
So their solution is to train their foundation model, Nova, to basically see and use websites like a person does, using the browser as its tool.
Giving it eyes and hands for the web.
Kind of. And NovaAct bundles this model with an SDK for developers to build on top of it. It's about translating plain English into clicks and scrolls on the screen.
Right. They showed that demo,
Yeah.
asking it to find like a 2-bedroom, 1-bath in Redwood City. And the agent just broke it down, planned the steps, clicked around the website, all from that simple request. Powered by their Amazon Nova model. That does sound useful.
And they showed more complex stuff, too, like pulling out specific details from property listings automatically, organizing it all neatly, structured data extraction.
Like scraping, but smarter.
Yeah, and programmable. It could even do things like figure out biking times to different places using Google Maps in parallel, then pop all the results into a table you can sort.
Okay, that's getting pretty powerful.
And the kicker, they showed you could get a basic version running with just like 3 lines of code, making it accessible.
Okay, but it can't be that simple under the hood, can it? I mean, just figuring out what an unlabeled icon on a random website means, that seems incredibly hard for an AI. We just know, but how does it know?
You're spot on. It's deceptively complex. That's why these agents need to learn through trial and error, essentially. Reinforcement learning, RL.
Learning by doing.
Exactly. Their digital perception needs to line up with ours for it to work reliably. A lot of current agents are more like LLM wrappers. They can talk and maybe use a few tools, but they don't really interact with the environment in the same way.
They're not grounded.
Right. These computer use agents, though, they see the pixels, they click the buttons. It's an early kind of embodiment, even if it's just digital.
A digital body.
Sort of. And what's really interesting about NovaAct is its focus on getting those tiny actions right, the atomic actions, making them reliable so you can chain them together into complex tasks, like building sentences from words.
Giving AI fine motor control for the digital world.
But, okay, to really grasp this, you mentioned history. Engelbart hinted AI has been around for centuries, but the sources you looked at suggest it goes back way further.
Yeah, way further. If you want to understand intelligence, especially general intelligence, connecting it to the bigger picture,
Yeah.
you arguably have to go back maybe 6 million years.
6 million. To our ancestors. Big environmental changes happened. Our ancestors basically had a choice. Get smarter or die out.
High stakes.
Very. And the ones who made it seemingly solved it through social intelligence. A social cognition feedback loop.
A feedback loop. How did that work?
Think of it like a flywheel. Brains got a bit bigger, which let us tune into each other better, understand social cues, cooperate, which then created pressure for brains to get even bigger to handle all that social information processing. Bigger brains, better social connection, bigger brains.
Wow. And the key was interacting with each other.
Critically, yes. We started offloading computation onto each other's minds, distributing the thinking across the group, the social environment.
Like a shared brain.
In a way, this massively augmented our intelligence, and it led to something called representational alignment. We got better at sharing what is in our heads, getting on the same page to cooperate.
That is a completely different way to think about intelligence, not just what's inside one's skull. So our genius isn't just individual.
A lot of it might be collective, yeah. The huge insight here is that upgrading intelligence didn't start with silicon chips. It started with us using each other's minds as tools.
Okay, mind blown again.
So human intelligence is general precisely because it involves this constant process of figuring out other minds, inferring the existence of other minds. Our intelligence isn't static or isolated. It's social, shared, always evolving.
And what was the key adaptation that let us do that?
Hmm.
Use each other's minds.
Language.
Language, of course.
Language seems to have co-evolved with our ability to model other minds. Another flywheel. Better understanding of others, better language, better understanding of others.
Integrating communication and thinking.
Exactly. As we got better at reading social cues, our mental models of others became more stable. This improved language, which then made the models even more stable. And that seems to have been the big bang for our intelligence.
A big bang.
Yeah, because these models of mind, our understanding of intention, belief, desire, became the sort of original variable, the first placeholder concept that allowed us to represent anything abstractly. That ability is generalization.
Well, okay.
And that's why human language is so different from, say, code or even what current LLMs do. Our words point to concepts that we understand minds create and share. Like the source beautifully puts it, what's in a word?
A
mind.
What's in a word? A mind. That really clicks. It unlocks the whole generalization thing.
Right. And because language was so powerful, it kicked off this cascade of other cognitive technologies. Writing, math, printing, each building on the last, letting us think more and more abstractly.
The continuous upgrade path.
Exactly. And it continues. Early computers weren't that useful until Engelbart fixed the interface, right? Made them work better with us. We're kind of at a similar point now with AI.
So bringing it back to today, agents like Novac could help fix the problems modern tech has created. The overload, the distraction.
That's the potential, yes. By handling the repetitive digital chores, learning our preferences, maybe even sharing useful skills across users, they could potentially become a sort of collective subconscious for us.
A collective subconscious.
That's a cool idea. These tools, these cognitive technologies, they shape our thinking. They direct our attention, controlling those hallucinations in a productive way, helping us build shared understanding. But again, there's that balance. They can free us or constrain us.
Right. So Novac is trying to provide the basic building blocks, the primitives, for a cognitive technology that helps align the agent's understanding with ours.
Exactly. Aligning representations and like writing or the printing press, these early agents will need to evolve out in the real world in diverse communities, learning from how we use them.
Making the digital world bend to us, not the other way around.
That's the hope, which, raises a big question. For agents to be truly reliable, to really get our high-level goals, eventually they probably need something like models of our minds.
Like we model each other, can we build that?
Probably not directly, but maybe we can create the conditions for it to emerge.
How? What conditions?
Well, you'd likely need a common language, a shared way for us and computers to communicate effectively. You need a shared model of the digital world in this case, and interfaces that feel intuitive, natural.
Okay. Language, environment, interface.
Get those right, and you might create a system where humans and agents can genuinely, reciprocally level up one another's intelligence, learning from all the interaction data, driving the creation of genuinely useful products.
And it comes back to that core idea. The more useful the products are,
The smarter we all become collectively, leading towards that useful general intelligence.
Okay. So wrapping up this deep dive, the big takeaway seems to be that the path to AGI, or at least useful general intelligence, isn't just about building bigger, faster AI brains in isolation.
No, not at all.
It's about coevolution. AI and humans evolving together, with AI designed from the ground up to augment us, give us more agency, make us smarter. And this whole idea is rooted in how our own intelligence evolved socially, through language and understanding other minds.
Precisely. It's a profound shift in perspective, and maybe that leaves us with a final thought to chew on. If our own intelligence really sparks from interaction, from inferring other minds, what happens when AI agents get truly good at inferring and aligning with our minds? What new kinds of thinking, what new forms of collective intelligence might we unlock if we successfully integrate these agents as a kind of collective subconscious into how we live and work? What could that mean for creativity, for learning, for problem solving in the future?